in contrast to some of the other talks I've seen, this is mainly a marketing pitch for some of the stuff that I do. And also, I'm not sure, I wasn't quite sure about the length, so I kind of, we'll try to keep it under 5 minutes. So my name is Eugene Wu. I'm assistant professor. I started fall 2015. That's wrong. I'm in the computer science department in DSI, and I work on both databases, data analysis, as well as kind of visualization systems. And so the main motivation for a lot of the work that I do is on this observation about this big data stuff. So typically people think of big data as this vast ocean of information, and with the right set of tools, there's patterns you want to surface, and with the right set of tools, you can really kind of blow these patterns out of the data, right? And so of course it is the case that if you have very powerful tools and you can afford these tools, you can make these observations and you can extract these patterns and insights. Now, I think the interesting thing that's been happening recently is that all of these other players, these small businesses, these research groups, individuals, and even people that don't really know what to do with data all have access to this very important and interesting resource. And so ultimately, a lot of the stuff that I think about is related to the fact that big data, in addition to volume and interestingness, is ultimately also about the people that are working with it. And so ultimately there, if we expand out from a very myopic view of databases, it's not simply just databases turn data into results. There's a lot of ecosystem around this. Obviously, it doesn't, like what I do doesn't capture everything that you want to do in data analysis, but I'm also interested in areas such as, well, how do you clean and import data and really kind of do data integration if you're collecting data from multiple resources? I'm interested in how do you visualize results and how do you build kind of modern, scalable data visualization systems to support these very exciting visualizations that everyone's been talking about. And also, ultimately, once you've actually performed some analyses, you'd like to understand your results a little bit better. So how can we build tools to help facilitate that? And so what I wanted to do is just talk a little bit about example projects in each of these areas that I work on. So in terms of cleaning and importing data, obviously there's a very vast set of things you might want to do. And along those lines, one project I've been working on is Clamshell, which is the idea that oftentimes automated tools aren't good enough, and you simply need to ask humans to do some sort of either entity resolution or tagging or labeling and so on. And in these cases, how do you actually do this in a scalable yet very, very fast way? Because if you typically just ask people to do work, it kind of follows a power law distribution where some groups of workers will be very, very slow. And so how can we make use of systems techniques to actually make this faster with some rough guarantees about latency? And then we're also interested in this problem of goal-oriented data cleaning. And so oftentimes, if you have a data set, you don't want to just spend your time cleaning it. That doesn't make a lot of sense. But what you often do is you have a goal in mind, and you'd like to be able to clean towards that goal. For example, if you want to ask a particular question, such as what is the result of a particular database query or a visualization, you want to make sure your answer is equivalent or roughly equivalent to what you would get if you clean the whole data set. Then how can we help facilitate that? So we're interested in those sorts of problems. On the analysis side, what I'm interested in is understanding results. And so I've worked on two among many other projects that help kind of facilitate this. And so Scorpion is this idea that you would like to explain the data that comes out of your analyses in useful ways. And then Query Fracker is the idea that instead of explaining data, you'd like to explain and understand what queries or analyses that transform your data introduced or caused errors in your database. And so to give you a concrete example of Scorpion, basically the idea is if you were to, say, visualize a large sensor net deployment, then you might visualize your temperature, say, like one attribute that you're collecting, such as temperature over time. And so what I'm plotting here is basically the average and standard deviation of temperature readings across an entire test bed on a per hour basis. So each point here corresponds to some statistic about the temperature readings for a given hour, right? And so we can see in this kind of visualization that interesting patterns start popping up. So for example, a natural question is, even though there seems to be a periodic pattern on a daily basis, there seems to be something wrong going on around here, right? Something seems to be happening. And it would be really valuable to understand what's actually causing this, right? Or what's correlated with this anomaly. And why is it not what the trend that we would expect it to continue having? And so Scorpion is basically a system that can help you generate these descriptions based on the data that's being used to generate these visualizations. So for example, Scorpion would then say, well, if you consider sensors that are near the window, then those are actually highly correlated with these anomalies. And the reason might be because the sensors are close to the window and they heat up dramatically during the day around noontime. So that's kind of an example of analysis explanation. And then the final aspect that I work on is in data visualization management systems. And so we all know that database systems help us manage data. Well, one thing that and one of the reasons it does this very well is because there's this high-level language called SQL that allows us to write high-level operations, and then the database can perform the optimizations to make the queries actually run fast. And so what we've been looking at is how can we take some of these ideas and translate them to visualization systems. So one of the limiting aspects right now for scaling visualization systems is the fact that most people write very low-level code, right? Either D3 code or other, C++ or very low-level code that's very difficult to analyze and very difficult to change as your data changes or as your data scales up. And so we're looking at a high-level language analogous to SQL that can help you both describe what you're trying to do in terms of building up and developing interactive visualizations, and then it's a high level enough as a language that we can then optimize it for you. The other aspect in terms of intersecting visualizations and databases is this idea of using application-level information in order to make these systems faster. And so one thing that we're currently working on is what we call perception-aware performance. And the idea basically is traditionally you're going to have a large collection of data, and you might want to create a visualization for it. Now it turns out maybe if your data set is very, very large, that can take a very long time. And so currently there are techniques where if you know, say for example, the output visualization is going to be 300 by 300 pixels, you don't need to compute that much information because you know the output is only going to be at a certain resolution. Now, what we're really interested in is going a little bit further and thinking about the semantics. So basically, even if we do this resolution awareness, one question is what can the user actually perceive and what are the conclusions they draw from it, right? Because ultimately, that's what we actually care about. And so we're interested in kind of pushing this forward and thinking about how perception fits into this. And one reason this might make a lot of sense is because over time, we've seen that the size of the data that we have is rapidly increasing. So is, say, the screen resolutions as well as hardware performance. But one thing that has stayed constant and even sometimes drops over time is the accuracy of our eyeballs, right? So here we can see that over time, the accuracy of our perception decreases, and then you might buy some glasses or you update your prescription, and then it increases a little. And so if this is the case, then we like to shoot to provide perception-aware performance rather than looking at as scaling towards the data or the resolution or the computing. And so ultimately, what we're looking to do is develop perceptual models that we can borrow from the HCI community that runs these perceptual studies and then integrate them in our database community, which is kind of optimizing these things. And so that's basically a very, very fast run-through of a lot of the things that I work on. And basically, I'm here to just tell you some aspects of what I do, and then stick around afterwards where we can kind of chat for real. So ultimately, I'm very interested in the data problems that you have, and this is my information. Thank you.